Hey everybody, I'm Miss Emily and I'm going to be your facilitator today. First of all, before we get started, I just want to make sure everyone is staying healthy and safe and taking care of themselves, because I know times are weird and times are hard, but I know that we're going to get through it. So, let's get going. Before we get started, just like any other session, I want to make sure that we're following some of the guidelines that we have. First of all, you're in your home, so I want you to be respectful to the space that you're in. Second, I want you to hold yourself accountable. So there are going to be some times where I'm going to ask you to time some things or measure things. I want you to be accountable and make sure you're doing it well and doing it right. And then finally, obviously, I want you to have fun. If there are no questions, comments, or concerns, that you can comment below. Let's get started. The purpose of our session today is going to use problem-solving skills and trial and error to build a boat and see if that boat is going to withstand a storm. We're going to talk about that a little bit more a little later on, but first, before we do that, I want to talk to you about our agenda. So the first thing on our agenda is going to be a really quick warm-up, about 5 minutes or so. Then we are going to do our hour-long session. And then finally, we are going to debrief. So for our warm-up today, we are going to unscramble the word scientific method. Now, your instructions are find as many words as you can in the phrase scientific method. So for example, the word hot. If you unscramble it, you'll find the word hot, and you can write that down below. So I'm going to do this along with you. This is where I want you to use the guideline of accountability. So make sure you are using a 2-minute timer. If you don't trust yourself, find someone who will time you. And let's get to it. So I ended up finding and unscrambling for 30 words. It's a personal best. I tried this yesterday and I only got 22. So I may have cheated a little bit, I'm sorry. But 30 words in the warm-up. So a big question is, why are we talking about the scientific method? This is at school, but it's important to understand the parts of the scientific method, which again, we're going to talk about a little later on. But before all of that, I just want to kind of debrief with you. So why the scientific method? The scientific method is used as a problem-solving technique. And we use this in our everyday life. We just don't call it the scientific method. We problem solve, we use trial and error, and not only in school, but in our personal lives. So even though you're not going to use, maybe testing over and over again, you do use some parts of the scientific method to problem solve in your daily life. So, I want us to now sort of start working into our session. Overall, I want to reflect back on what we're doing in the objective of our session today, which is to practice problem-solving skills, trial and error, and ultimately build a boat to see if it's going to withstand a storm. With the introduction to the scientific method, a couple of things I want us to talk about are what the scientific method is and what are the steps of the scientific method. So to define what scientific method is, it's just a series of scientific steps to determine why things work, how things work, or just to determine what happens when you do this, X, Y, and Z. So with that being said, let's talk about the parts of the scientific method. So today we're going to be working with 6 different parts. The first one being to observe and question. So observing the natural world, observing what's happening in our world, and question later to form a hypothesis, which is step number 2. So we observe, we question, we form a hypothesis, and a hypothesis is just an educated guess. And once we get to the end, I want you to remember if your hypothesis is wrong, it's okay, because it was only a guess to begin with. Third, we're going to test our hypothesis. 4, we're going to collect the data. So as we're testing, we're going to collect the data or take notes, write down what we see and what we observe. 5th, we're going to analyze that data and put it into a more uniform, more cohesive, to make it look a little better. That's what I'm trying to say. And then finally 6, we're going to draw our conclusions. So we're going to go back to step number 2, look at our hypothesis, and we're either going to accept or reject our hypothesis. And it's okay if you have to reject it because, again, it was only a guess. So with that being said, I want to give you a little bit of background information. So why is all of this important, and why do I keep talking about boats and shipwrecks? I am fascinated with shipwrecks. Everything from literary shipwrecks, like in The Wreck by Alfred Tennyson, which is a poem where a married woman loses her lover in a shipwreck, and she says, "My life is a wreck, my brain is just crashing waves." So she's a little distressed. And then you also have stories like the Titanic, which is a little bit more saddening and hits a little bit closer to home. But you also have stories like the La Jula, which was a shipwreck just off of Senegal, which is in Africa, and it sank in 5 minutes. So I want us to test the theory. Can we build a boat that will withstand a storm? So that is my observation, and that is my question. That is step number 1 of the scientific method. So my question is, can I build a boat that will withstand a storm by measuring 3 different measurements? And again, we're going to get to that in just a little later on, and we'll revisit that question. For this session, you will need plastic bin, measuring cup, yarn or thread, 10 nickels, measuring tape, 3 feet of aluminum foil, 2 gallons of water, a pen, and a piece of paper. Now that you have all of your materials ready and available, we need to start prepping them. So the first thing you want to do is fill your plastic bin with the 2 gallons of water. The next thing you want to do is take your cord or your yarn, whatever you may be using, and measure it into 3 sections. So the first section will be 12 inches, 10 inches, and 6 inches. So I'm using a cord here, and I've just taken my tape measure and measured it off. And again, that's 12 inches, 10 inches, and 6 inches. The next thing you want to do is start building your boat. So you want to use your 3-foot section of aluminum foil to start building your boat. My suggestion is that you use your pen and paper from earlier to make a design. That way you know how to build your boat and you're not just doing it from scratch. So we have our boat built. I have some notes here on my boat. You can check that out. I'll put a photo for you to see it a little better. Anyway, so I have my boat built, and now we need to start the experiment. So again, we need to reflect back on the scientific method. The first step of the scientific method was to observe and question. So we've observed the natural world, we see shipwrecks happening, and we want to know if we can build a boat that will withstand a storm. Now, there's a second part to your question, or at least to my question. So for my step 1, I've observed, and now I'm going to question, can I build a boat that will withstand a storm when a ball is dropped from 6 inches, 10 inches, and 12 inches from the water's surface? This is going to create my storm. Now we need to do the next step of our scientific method, which is to hypothesize. And I hypothesize that my storm will sink my boat at 6 inches because the waves will be more intense from the shorter distance. I believe that the 12-inch distance, the 12-inch drop, will be the safest for my boat. And then finally, I do not think that the 10-inch distance will have any effect at all. So the next part of our scientific method would then just be to test it. Now I'm going to do one test, test number 1, which is going to be our control. And our control just means, our control group just means that this is the test where everything is normal. We have something to compare it against. So what we're testing here is, will my boat float, or will it sink? And then also we're going to test in this, will it hold my passengers, which will be my 10 nickels. If you do not have nickels, you can use pennies, you can use marbles, just something of the same size and about the same weight. That way it doesn't interfere with your tests. All right, so test number 1, will it float and will it hold passengers? Okay, we're floating. Now we're going to add our passengers or our nickels. So we are testing again. Test number 1 is our control group to see if we are able to float and if we're able to hold passengers. So for test number 1, we are floating and we are able to hold at least 10 passengers. This is a good thing, but remember, this is only the control group. So that means again that we're testing for what is normal. So on a beautiful day in our ocean here, we are able to hold passengers, we're able to float, and everything is going well. So the next part of our scientific method is to continue testing, but now we need to test our stormy weather. So again, to demonstrate our stormy weather, we are going to use our string, our cord that we measured out earlier. Again, we're using it at 12 inches, 10 inches, and again at 6 inches. And what we want to do is begin at each distance. We want to put the bottom of our cord at the surface of the water. We don't want it below the surface. We want it right at the top of the water. That way we know the exact distance and the exact measurement from the bottom of our ball to the top of the water. So we're going to drop it 3 times consecutively, which means we're going to drop it 3 times back to back to make sure we get a consistency. All right, so let's test distance of 6 inches. This will be test number 2, dropping the ball 3 times. Okay, so we have a little bit of water. We took on a little bit of water from the splash, from the rain is what we'll call that, I guess. But we are still floating and everybody's safe on board. So 6 inches, 6-inch ball drop seems to be pretty safe for our boat. Okay, this will be our 3rd test. Remember, test number 1 was the control. Test number 2 is from 6 inches. This will be test number 3 from 10 inches. The bottom of the ball should be in line with the knot. The end of your measuring cord should be on the surface of the water, and let's test it. Okay, so I'm wet, but our people still a little wet inside there, but we are not taking on water. We did not cause too big of a storm, it doesn't seem like, and everybody is safe. Now we're going to do the final test, and the final test will be from 12 inches. Again, back in our hypothesis, we said that 12-inch drop would be the safest. So let's see. All right, final test, test number 4, dropping the ball from 12 inches. Bottom of your ball should be in line with the top knot or at the 12-inch mark, and the surface of your water. I'm about to run into a problem here, so you don't want to drop your ball onto your boat, okay? So just move your boat out of the way if that ends up happening. So here we go, test number 4. Okay, so test number 12, one thing that I observed, test number 4 from dropping at 12 inches, one thing I observed was the waves did become a little bit more severe. So the higher the ball was dropping from, the more the boat rocked. So whenever we take notes and whenever we do notes, that would be something to be sure to include in that. So if we look at our people, our passengers are still safe, our boat is still floating. Now, here is something that you should take note of. If your boat starts to sink, if your boat starts to float, or if it takes on water and capsizes, which means it turns upside down, you may need to go back, change what you did, look again at the design of your boat, and then redo it. So again, this goes back to our objective of problem solving. We want to make sure that what we are doing is the most efficient and the most effective. And that would be to build a boat that will withstand a storm. The final part of our scientific method here is going to be to draw our conclusion. Now we can accept that 10 inches did not really cause much of an impact on our boat, which was part of my hypothesis. I don't know if I actually mentioned that or not, but we can also reject that 6 inches was going to cause the most damage. We can also reject that 12 inches was the safest. Again, your hypothesis is only a guess, so if it is wrong, if what you tested didn't prove your hypothesis, whatever it may be, it's okay. It just goes back to trial and error and problem solving. So you can rebuild your boat, redesign it, and maybe make one that will withstand your storm. So for our debrief, I just want to overview. The first thing we talked about was the scientific method and defining that scientific method. Remember, it's just a series of scientific steps that you can take to figure out why things work, how things work, and what happens when things work. Then we talked about the parts of the scientific method. Remember, there is observation and questioning, there is hypothesizing, testing, there's also analysis, so you analyze the data, and then finally draw your conclusion, and that is either you accept or reject the hypothesis that happened. And again, for ours today, we could reject most of it, and we were able to accept only one part that says the 10-inch ball drop was going to be the safest. Now, one thing I want you to think on is, in this weird time, how can you use the scientific method? How can you use it not only in school? Again, I want us to reflect on the fact that we talked about that we use the scientific method, or parts of it anyway, in our everyday life. One of those being to problem solve and using trial and error. So the next time you find yourself in a situation where you might need to problem solve, what is the best and most effective way of solving an issue? Regardless if it's in school, it could just be in your daily life with a friend, with a family member, you never know. And then I want you to think about how we can use trial and error. If this didn't work, how can we fix it to make it better to work? So those are the big things I want us to take away. If you have any comments or questions or concerns, feel free to comment on the video. If you did this activity and you had a successful boat, and it was able to withstand the storm, it would be really cool if you have Instagram, send it over to Instagram, and then make sure you tag Girls Inc. Memphis. We want to see what you're doing. Anyway, I hope you all stay safe. I hope you all are healthy and having a good time while you're out of school. Find ways not to be bored. Don't sit on your phone. Have a good day.